In the second part of Mod 4, we are going to look at the graphs of the tangent and cotangent functions. We're going to start out by looking at the tangent function. Remember how tangent is defined. Tangent is defined as y over x. If we go back over to our unit circle and start looking at our y over x's, at 0, y over x would be 0. At pi over 2, y over x would be undefined. You'd have 1 over 0. So when you have 0 in the denominator, what that means is that that would be an asymptote. If we come down to 3 pi over 2, or going down, call it negative pi over 2, and do y over x, we would also have undefined. So in order to graph the tangent function, we're going to look at just the first quadrant and the fourth quadrant. When we are in the fourth quadrant, we are going to use the negative version of those angles instead of the positive version of those angles. We're going to do that because at the pi over 2 and negative pi over 2, you have asymptotes. So that's the reason that we are looking at just these two quadrants. So let's start at the smallest and do negative pi over 2. At negative pi over 2, we said that this thing is undefined. So that will be an asymptote. We need a little bit more information than just the values of the axes in order to help us see the shape of this function a little better. The standard that we use is the pi over 4s. So we're going to do negative pi over 4 next. If I look at negative pi over 4 and I put the y over the x, the y and the x are the same value except that one's positive and one's negative. Any number over itself is 1, and since we have a negative and a positive, it's going to be negative 1. At the angle value of 0, if we put the y over the x, we get 0. At positive pi over 4, we have radical 2 over 2 over itself, so we get positive 1. And then at positive pi over 2, we have undefined again, so that is another asymptote. Just like on the sine and cosine functions, the tangent functions go through these values repeatedly. So in setting this up, we have negative pi over 4, and we have negative pi over 2. Now remember, at negative pi over 2, that was an asymptote. We use 0, positive pi over 4, and positive pi over 2. And again, at positive pi over 2, you have an asymptote. The other values that showed up in our table were 1 and negative 1. So we'll put those on the y-axis, the vertical axis. At negative pi over 4, our value was negative 1. At 0, it's 0. And at positive pi over 4, it is positive 1. Now remember what an asymptote is. An asymptote is a line that you get closer and closer to, but never touch. The other thing about the tangent function is that it goes up and down forever. So it's going to go down forever, towards that asymptote, and then up forever towards the right-hand asymptote. So it has kind of this S-curve look between the two asymptotes. And then again, like I said, this would repeat over and over and over again. What I want you to note on here is that the period length for a standard tangent graph went from negative pi over 2 to positive pi over 2, and that in total is pi. As far as amplitude goes, there is no such thing as amplitude because tangent goes up forever on the right hand and goes down forever on the left end. Next up, we're going to look at a graph of a basic cotangent function. Remember how cotangent is defined. Cotangent is x over y. If we put x over y at 0, we are going to get undefined. So there's our asymptote. If we put it x over y at pi over 2, we're going to get 0. If we go over to pi, we're going to get the undefined again. So there's our other asymptote. So the boundary that we use for the basic cotangent function goes from 0, where the first asymptote happens, to pi, where the second asymptote happens. So this is undefined, which is an asymptote, and so is pi undefined, which means we have an asymptote there. Going by what we did on the tangent graph, we also use the pi over 4s to get a little more shape on this graph. So at positive pi over 4, if you put the x over the y, you have radical 2 over 2 over itself, which is 1. At pi over 2, you put x over y, you get 0. At 3 pi over 4, you have radical 2 over 2 for both coordinates, but the x coordinate is negative. So you get negative 1 this time. So this graph is very similar to the tangent graph in several ways. What is different is that our first mark is at 0 this time, and that will be an asymptote. And then we have pi over 4, pi over 2, 3 pi over 4, and pi, which is also an asymptote. Our high value that we have is a 1, and our low value is a negative 1 as far as the values of cotangent that we found. And now if we plot these points, at pi over 4, we are at 1. At pi over 2, we are at 0. At 3 pi over 4, we are at negative 1. But we have asymptotes again. So remember that asymptotes mean you are getting closer and closer to that and going on forever, but never touching it. So on both sides, we have asymptotes. We have another S-curve looking item, but this time it's high on the left and low on the right, where tangent was the reverse of that. If we think about the period of this, how long did it take us to go through one cycle? Pi. Amplitude is not applicable on these problems because it goes high and low forever. The rules that we talked about for moving around or changing the shape of trig functions when we were graphing sine and cosine will hold true when we graph tangent and cotangent. In looking at example 7, where we want to graph one period of y equals the tangent of 4x, let's go back and think about our letters here. A, the number out front, is a 1. What that's going to affect on tangent and cotangent is just what number you put on the vertical axis. Since this is 1, it's going to stay the same as the basic functions and be a 1. The b is what's right in front of x. In this case, it's 4. And the c, there is no c, so you can think of that as 0. Period. Remember, to find period, you always take standard period length. Standard period length for tangent is pi, and put it over your b. So instead of going through one cycle in pi, we are going to go through one cycle in pi over 4. Our increments, we do the same thing we were doing before. We take pi over 4, and since this is a fraction already, instead of dividing by 4, I'm going to multiply by 1/4 and get pi over 16. Because c equals 0, there is no phase shift. When you are graphing a tangent or a cotangent function, it's really important to know that you must work off of the point where the function crossed 0 in the basic function. A tangent function crosses 0 at 0. So because we had no phase shift, that stays the same on this problem. Our increments from that 0, we're going to count by pi over 16s. And what's a little bit different from when you graph a sine or a cosine, from a sine or a cosine, you just start at 0 and count out 4 more places. On a tangent or a cotangent, you find where you are on the x-axis, and then you go 2 to the right and 2 to the left of that point. So we are going to go 2 marks to the right and 2 marks to the left, and we're going to count by pi over 16. So the first mark will be pi over 16, and then the second mark, pi over 16 plus pi over 16, is 2 pi over 16, which simplifies to be pi over 8. The second mark over is always your asymptote. Going to the left of our 0 value, 0 minus pi over 16 is going to put us at negative pi over 16. Negative pi over 16 minus pi over 16 gives us a negative pi over 8, or negative 2 pi over 16, whichever you prefer. The second mark over is always the asymptote. The vertical axis, we will use the value of a. In this case, it's 1, so we'll have 1 and negative 1. And then recognize that this is a tangent function. Tangent is low on the left, so at negative pi over 16 will be low. Then we have the 0, and at positive pi over 16, we have the high. Now connect your points using your asymptotes, knowing that you're going on forever, and there is your function. On example 8, we are graphing one period of the function y equals 3 times the cotangent of 1/2 x. So on this problem, our a is 3, our b is 1/2, and c is, again, 0. Because a is 3, the markings on the vertical axis will be 3. So keep that in mind. B, having a value of 1/2, is going to change our period. So let's do our formula for period. Standard period length for cotangent is pi. Pi divided by b divided by 1/2 is the same thing as pi times 2. So our new period length for this cotangent function will be 2 pi. The increments, take the period length you just found, 2 pi, divide it by 4, so our increment will be pi over 2. No phase shift on this because c is 0. We know that there has been no phase shift, and we also know that 0 is a place where cotangent is undefined. So we know that 0 is still an asymptote. Our period length has to be 2 pi now, so that means that the other asymptote has to happen at 2 pi. Now, halfway between the two asymptotes is where the 0 happens. So halfway between 0 and 2 pi is pi. Halfway between the asymptotes and pi has to be your highs and your lows. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. Our a was 3. So our vertical axis, we need a 3 and a -3. Our 0 is happening at the center. And then this is a cotangent function. Cotangent starts high, ends low. So putting this in between our asymptotes and following our points, there is the graph of our cotangent function. On example 9, we are going to graph one period of y equals the tangent of the quantity 2x minus pi. A on this one is 1, B is 2, and C equals -pi. Our labels on the vertical axis will be the A value, which is 1. Period, because this is a tangent function, we take standard length of pi divided by b, so our period is pi over 2. Our increments will be pi over 2 times 1/4, which is pi over 8. Our phase shift. We are going to have a phase shift this time because we have a C. You do the opposite of your C, so we're going to do positive pi divided by B, which is 2. This does not simplify, but remember we want a common denominator between increments and phase shift. So I'm going to think of this as being 4 pi over 8, so that now I have a common denominator for those two items. When you need to do a phase shift on a tangent or a cotangent graph, you move the point where the basic function crosses the x-axis first, and then you find the other values off of that new point. Because this is a tangent function, the basic graph crosses at 0, 0. So instead of crossing at 0, this function, because of the phase shift, will now cross at pi over 2. So there's our 0 point. I'm going to put the common denominator version of that down below, 4 pi over 8. Our increments are pi over 8. Remember, we need 2 marks on each side of this 0 value. So the first mark to the right, 4 pi over 8 plus pi over 8, is going to put me at 5 pi over 8. The second mark will be 6 pi over 8, which is 3 pi over 4. And the second mark over is our asymptote. Do the same on the left. The first mark over, 4 pi over 8 minus pi over 8, will put us at 3 pi over 8. 3 pi over 8 minus pi over 8 will put us at 2 pi over 8, which is pi over 4. And the second mark over is our asymptote. Do a quick check. If I take 3 pi over 4 minus 1 pi over 4, I get 2 pi over 4. And if I simplify that, I get pi over 2, which is the period length that I'm supposed to have. My high and low values are 1 because a is 1. This is a tangent function, so it starts low, ends high, and then we put in our curve between our asymptotes, and that's the graph of this function. The last example for tangent cotangent, we are going to graph one period of the function y equals the cotangent of the quantity 3x plus pi over 4. Our a is 1, b is 3, and c is pi over 4. So our mark on the vertical axis will be 1, since a is 1. Our period, standard period length for cotangent is pi, divided by b gives us 3. The increments will be pi over 3 times 1/4, since it's already a fraction, which gives us pi over 12. Our phase shift. We're going to do the opposite of our c, so we're going to do negative pi over 4, put it over our b. This means we have negative pi over 4 times 1/3, which is negative pi over 12. And it's very convenient that our increments and our phase shift are already the same denominator, so we don't have to mess around with that. Now remember that when you need to do a phase shift on a tangent or a cotangent, you have to move the 0 value first. On cotangent, the 0 value is at pi over 2. And I need to move pi over 2 left pi over 12. Let's get a common denominator first. Our 0 point is pi over 2. But we can rewrite that as 6 pi over 12. So we need to take 6 pi over 12 and go left 1 pi over 12. So by moving left, pi over 12, our new 0 is at 5 pi over 12. So my 0 value is at 5 pi over 12. We need 2 values each direction from that. Remember, we are counting by pi over 12s. So 1 to the right will put us at 6 pi over 12, which is pi over 2. And the second one to the right will put us at 7 pi over 12. And that second one is our asymptote. Moving to the left, 1 pi over 12 to the left of 5 pi over 12 will be 4 pi over 12, which equals pi over 3. And the second one to the left will be 3 pi over 12, which is pi over 4. And the second mark over is our asymptote. The values on our y-axis are 1 and -1. This is a cotangent, so it starts high on the left, is low on the right, and then when you put that in, there is the graph of this cotangent.